Thanks, Tim. That's a good, strong name you've got. I like it. Yeah, I didn't know if like the rubbing the head thing was like, maybe that was a Polish thing. That was my introduction to Poland, so but, maybe not. The brain is a really remarkable thing, isn't it? I mean, think about what's happening right now. You're sitting there watching me and listening to me. This is something that's seemingly fairly passive, certainly something that nobody's going to consider to be exhausting, at least I really hope not. And while you're doing this seemingly passive activity, your brain is working like crazy. See, what's happening right now is it's receiving all sorts of sensory information. It's receiving information about what you're hearing and touching and smelling and seeing and what the temperature is. And it's trying to take all of these different inputs and use them to create a picture of reality as you're experiencing it right now. Now, this is a very complex task. Each of these different types of input have different forms, and they're processed at different speeds. So, for example, touch is processed much more quickly than sight or sound. And yet, if I do this, my brain takes the sound, the sight, and the touch, and it puts it all together, and it says that was one thing. That was one distinct unified event. So it has to parse all this stuff. It has to line it up in order. It has to filter through and discount the stuff that you're receiving that doesn't apply to this situation. There's also other things that I'm seeing and hearing and smelling right now, but they don't deal with that clap. So that it just ignores all of that. And then it applies some pattern recognition to try and infer some sort of meaning. And these patterns are based on our experiences and our beliefs, which is why, if you look at a piece of toast, you see a piece of toast, and a friend might see, God or a rock star sitting inside of there, right? It's the past experiences and beliefs that inform those patterns. But this pattern recognition is really, really powerful. It's what allows us to take a series of dots and lines and shapes, and if we arrange it just so, we perceive that there's a face here, even though there's not. It's just a bunch of black dots and lines. And this is why people say, that perception is reality. Now, this isn't 100% true, right? I mean, the edge of this stage is very real, and if I fall off the edge of this stage, there's going to be very real consequences, okay? Some parts of reality are just fixed, no matter how I perceive them. So I prefer to say that perception frames reality. How we experience each individual moment of our day is made up of all of these perceptions of those experiences. That's what builds it all up. And the whole thing is incredibly impressive, but it's also fairly fragile and prone to manipulation. Does anybody know who this is? You can just say it if you know, right? This is President Obama, right, from the United States. And it seems fairly normal. Everything seems okay. But if we turn this right side up, yeah, suddenly we're going to have nightmares. I think hopefully the conference will provide some sort of counseling or something. It's creepy, right? The eyes are messed up, the mouth is not right. But we don't see that when we look at this. See, what happens is your brain looks at this and it sees the basic face pattern. It sees eyes and nose and mouth, and it puts that all together, knowing what a face is supposed to look like, and that's how it translates it inside of your head. And it's only when it's forced to look at it straight on that it realizes just how messed up this really is. These are two wonderfully bizarre abstract shapes. One of these is called a kiki, and one of these is called a booba. Very fun words to say, by the way. This is actually, I rehearsed this slide like 500 times because I could say the words. It's a good time. Who thinks that shape A is the kiki? Okay, who thinks that shape B is the kiki? I see like almost no one. Almost no one. All right. There's no right answer here. These are two abstract shapes with no distinct name. And yet, when this study is done, this experiment is done over and over and over, and it's repeated, over 90% of people will say that shape A is the kiki. Now, the way this works, the theory behind this is that when you say kiki, is a very sharp sound, and in fact, your face takes on sort of a sharp angle, your mouth does. And when you say booba, it's a much more full sound, and your mouth rounds out, So your brain is sitting there trying to figure out what this is. It's trying to make sense of these crazy-looking things, and all it has to go on is how these words sound and what the shapes look like. So it sees sharp angles, and it sees the and it assumes that they're connected. It infers meaning where there is none. So the brain is impressive, but it's also fairly easy to mess with. And it turns out that time is one of the easiest ways to throw it off. Who here thinks that 300 milliseconds is a really, really long time? There's a couple hands, and I love asking this question because those are the people probably doing performance optimization within their organizations, right? They're the performance, and it's like, yeah, that is terrible. No, okay, 300 milliseconds. I want to show you what 300 milliseconds is, and I thought about the most exciting way to demo it was to move this square from one side of the screen to the other. Really exciting stuff. Everybody ready? All right, that was 300 milliseconds. Let's do it one more time. Again, okay, now I'm just going to go out on a limb here, but I'm guessing that there's nobody in the audience who is thinking right now, oh my God, that is 300 milliseconds of my life I am never getting back, right? I don't think anybody's thinking that right now because it is not a long time. And yet, there's this wonderful video of people walking around with an Oculus Rift on their face. And they see everything that they're seeing, but with a 300 millisecond delay. They see a little bit of lag, and it turns them from, I assume, fully functional human beings into a bunch of complete oafs, right? It doesn't take very much to throw us off. And it turns out that when it comes to digital interfaces, we're susceptible to even more minor delays than 300 milliseconds. There's been numerous case studies that show that even something as small as 100 milliseconds can make a measurable impact. Most notably, Amazon and Walmart came out and showed that for every 100 milliseconds that they shaved off their load time, they saw a 1% increase in revenue. And again, nobody is sitting there. None of their users are timing this and saying it's 100 milliseconds, I'm not going to order that yodeling pickle. Nobody's doing that, right? What happens is there's just enough friction now in the experience that is altering their behavior in some sort of measurable, meaningful way. In fact, 100 milliseconds is actually a really important threshold. There were studies in the late 1960s that showed that if a user takes an action and the digital interface responds within 100 milliseconds, it feels instantaneous. There's a very direct connection there. And if the same study found that 1,000 milliseconds was how long you had to maintain a state of flow, anything longer than this, and people's, they start to lose a little bit of focus on their task. So these are really, really important benchmarks. But they also present a very significant challenge for us on the web. I say challenge because I try to be optimistic, not problem here. So let's say that I was going to load front trends, for example. And we're going to focus on just the initial request. Just, I type in 2016.fronttrends.com and hit enter. Here's what happens. The first thing is the browser needs to figure out where this lives. Like it has to translate that fronttrends.com to an IP address at some physical server somewhere. So it does a DNS lookup. Ideally, this is happening like it's cached in your browser or operating system, so it's instant. The reality is that's not always the case. If you go into Chrome, they have one of those little super secret Chrome features that they do, where they have Chrome://histograms, and there's one for DNS resolutions, and it'll show you how long it takes. 80% of the ones on my machine take around 100 milliseconds or less, somewhere in that range. So this is not usually cached, unfortunately. After it's got the IP address, then it needs to establish a TCP connection. It needs to open up a connection to that server. This involves a three-way handshake. I have a colleague who calls this the yo, sup handshake. He doesn't get out much. So once you've got the connection established, then increasingly we are serving our sites over HTTPS because security is important and because browsers are taking some of our toys away if we don't, which is actually a good thing. I'm all for it. But this means that there's an extra SSL negotiation step in the process as well that requires potentially another couple round trips. And then finally, at this point, we are able to request our HTML and get that back. And if it's small enough, within that 14K or so, we get it back in a single trip. And if it's bigger than that, we actually have to keep going back out to the server back and forth until we get the entire file downloaded. Requests are very expensive. If we put some numbers on this, again, looking at that 100 milliseconds based on my own, personal use, and then let's assume that it's a decent network. This isn't too bad. 100 milliseconds for the round trip for the TCP connection, 1 to 2 for the SSL negotiation, and 100 milliseconds or so for the request. This is a really ideal scenario, and it still comes out to about 400 to 500 milliseconds. Now, if this was like some sort of a mobile network, it would be terrible. It has to do this negotiation with the mobile towers up front. The latency is much, much higher. So when I say that we're blowing half of our performance budget on this, just the overhead for a single request, that is best case scenario. And this is why every performance advocate ever has said at one point or another in their career that the fastest request is no request. And I do mean we have a club, and one of the things you have to do to be in the club is you have to commit to saying this twice a year. You also have to master the secret three-way handshake. It's a very intense group. And I kid a little bit, but this is a really important thing to remember because everything that you add to your page needs to have some significant value because everything that you add to your page has a significant cost associated with it. Every little image, every little JavaScript file, there is always a trade-off that you're making. There's nothing that's coming for free. And so it's important to sit there and be like, do we need this big fat hero image sitting here on this page? Is there value coming back from that? Now the challenge we face is that increasingly the answer is yes, because while people are expecting faster and faster sites, they're also expecting higher fidelity and visual richness, right? They want the best of both worlds. So the question we have is, how do we balance this richness, this fidelity of experience with performance and speed? Now this is typically where I would jump off into a nice long list of technical optimizations, which you've probably heard a million times in just about any performance talk. But I think that that's why we've had such a hard time in our industry shaking this performance is the developer's responsibility thing. You know, I think we've made progress on this. Certainly, a lot more people are talking about it now and how like it's everybody's job to build performance. You know, but I don't think it can be overstated just how important it is for everybody to get involved with this, because there's very serious risks to just leaving it to the technical side of things. There was a multi-story office building in New York City years ago. They got a lot of complaints about the elevators and how long it took from the elevator to get from the top to the bottom, you know, especially during peak time when everybody's getting on every floor. You know, it's a really slow experience. But the complaints were so much that the building manager felt like he needed to do something. So he had some research done. He brought in some engineers to analyze things and measure it and kind of play with everything. And at the end of it, the engineers concluded, you know what, we can't do anything about it. Unfortunately, this is as fast as these elevators can go. There's nothing we can do without risking safety or something like that. Now, this wasn't going to work because of all the complaints, so the building manager did what managers often do. He called a meeting. And while they were in the meeting, the legend has it, there was one employee who was a recent psych major, and he thought about the problem from a different angle. While everybody was focused on the technical problem of the elevator being slow, he ignored the elevator and he focused on the people in the elevator. And he said, you know, we have a lot of things that we wait for every single day. Why is it this thing? What is it about the elevator ride that makes us complain about it? And so his theory was that, well, maybe people are bored, right? I mean, we're shoving them in this little metal box with a bunch of people that they may or may not know, and they go up and down, and there's nothing to do, right? Maybe they're just really bored. Now, today, our solution to this would be to hand everybody an iPad and tell them to play Candy Crush or something like that. But this was before the iPad, iPhone days, so he had to think a little bit outside the box, and his solution was mirrors. The way he rationalized this was, if you put mirrors inside of an elevator, now I can stand there and I can watch myself in the mirror. In fact, I can actually kind of keep tabs on the people who are with me in the elevator, and it's a lot less creepy than when you do this and like kind of stare at them. I've done that. It gets awkward quickly. So the idea was, with a mirror, you could have something that you could be doing and thinking about and processing as you're going up and down the elevator, and sure enough, the complaints about how slow it was went away. Now, the takeaway here isn't that we are vain creatures who like to stare at ourselves. Not all of us are. The takeaway is that the performance is about the user, right? It's about their perception of it. It's about their experience. You know, that's what really matters. That's what it comes down to. So let's back up too, and then look at the elevator example again. Why did the mirror fix it? Like we kind of know that they were keeping busy, but there's some interesting stuff behind how we think about this stuff. So the experience can be defined this way. Well, you have a starting point, is where we entered the elevator. You have an end point where we got out of the elevator, and then you had all this time in between where we were waiting. When we wait, there's two basic forms of waiting. There's passive and active. Okay, so active is like, I have something that I can do that leads to the conclusion, right? So if you're walking through an airport to get to your bag, the walking part would be the active state. Passive is, I don't really have any control of this, so there's nothing that I can do, mental processing or physical, that is going to contribute to the result that I need. So passive would be sitting at the bag carousel waiting for the luggage to get out, that sort of thing. So when we're in the elevator and we have nothing to do and nothing going on, this is all very, very passive. And the problem with passive waiting is that studies for around queuing have shown that people who have to wait passively versus actively, there is about a 36% is how much they overestimate that wait time by. Passive is really, really boring, and every second of it feels excruciating. Now, there's some really clever ways to get around this. One of the things that I love that iOS did, I think starting with iOS 7, was in Safari. When you wanted to open a link in a new tab, you would go ahead and you'd tap on this, and when it does, there's this nice little animation. Now, as we saw in Rachel's presentation, I know she mentioned some of the stuff there with the visual cortex and helping create connections. There's that going on, but in addition, when you're tapping on this, as soon as you tap open a new tab, what it does is it's starting to load. So while that animation is taking place, Safari's getting about a 200 to 300 millisecond head start. And as we saw, this 200 to 300 millisecond head start can be a big deal. It can make a big difference. Now the whole idea of sort of getting ahead of the game, doing sort of this preloading and pre-browsing used to be very difficult, but it's gotten much better now with the introduction of resource hints. So in like 2011, I think it was, WebKit first started writing about this pre-parser, preloader. You know, I think Microsoft was either at the same time or even slightly earlier. There was a few articles coming out. Everybody kind of came across this idea that when we're looking through the HTML, why not try to get ahead of the game and try to load some of these assets earlier, you know, try to make these connections as early as we can. Resource hints lets you, the developer, talk to the browser and communicate about what assets need to be loaded and when. And then what it does is it lets the browser get some of this overhead out of the way ahead of time. So resource hints can be included in the page in 3 different ways. There's a header you can add, a link header. You can include it as a link element, just like you would a style sheet. And then you could also include it dynamically using JavaScript, which is where it gets really interesting, because now you could go based on some user interaction. If they click this, then let's go ahead and preload this asset or start to load this page. There are 4 basic options. Preload technically, by the way, is not a resource hint, but everybody lumps it in the conversation with resource hints, so I'm going to do it too. But technically, it's its own little thing. DNS prefetch is the simplest, the one that's also the least impactful. DNS prefetch is saying, let's say that you have some sort of a third-party script, and you don't know what the full URL is going to be of either the script or the image that's coming from the third party, but you know the domain. So you can pass it the domain, and what this tells the browser is go ahead and do the DNS lookup ahead of time. You can get that out of the way. Now again, this may give you a boost of about 80 milliseconds, 100 milliseconds, or it may do nothing, like you know, because maybe it's already cached. So this is the least impactful, least risk. Preconnect, which is basically DNS prefetch on steroids. Preconnect says the exact same thing. I don't know what it is, but I know it's coming from that domain. But instead of just doing the DNS lookup, let's go ahead and open up the connection, do the TCP connection, the SSL negotiation, go all the way. Just basically, we've got an open connection to the server now. So it's much more powerful, much more impactful. And frankly, you should always just be using this instead of DNS prefetch when it comes down to those 2. I would pair them together for now because DNS prefetch support is better. So if you include them inside of your HTML like this, what the browser is not going to open 2 separate connections. It's not going to try to go through the process twice. It's going to see that it's the same domain and collapse it. But this lets you use DNS prefetch for browsers that support. Browsers that don't support preconnect would ignore it. And if the browser does support preconnect, you get all the benefits of that. Preload is for individual assets. So saying, I know I'm going to need this style sheet or this image or this JavaScript file, go ahead and bring this down as soon as you possibly can. Don't wait until you find it. I know you're going to need it. Just go grab it. So in this case, it goes through the entire process, gets the asset just waiting there locally in cache to be used when it's needed. And finally, pre-render. Pre-render is a beast. Pre-render is basically what you're saying is this is about the next page. This is saying, okay, I think the user is going to go to this page next. What I want you to do is render the entire page ahead of time. So think of it, there's an invisible tab, and the HTML is loaded, the CSS is applied, the JavaScript runs, everything happens. And then when the user goes to that page next, boom, it's like an instant swap. It is amazing. Like when you've seen it work, it's like, oh, this is so good. It's just instantaneous. Forget 100 milliseconds. It is just right there. It does this entire process. But that also makes it incredibly risky, because what happens is if you try to pre-render a bunch of pages and the user doesn't go there, guess what? You've just used a bunch of their data for no reason at all. Now, it's going to be hard for them to blame you for that, but that is not an excuse. I just want to put that out there. That's not an excuse to do it. So there is a risk here, right? If you do it, I talked to one organization when pre-render was first kind of coming out, and they were like, this is great. We're going to pre-render everything. And they put like 15 pre-render links in the head of the page, like just in case they went to any of these like 20 different pages. And not only did they blow through data, but they were actually crashing browsers at point early on because the browsers kept opening everything up. Now, I think the browsers have gotten much smarter since then. That's a fairly safe thing. I haven't tried to kill them yet, but maybe it's possible at some extreme limit. But you do want to use this one with care, because we aren't always the greatest at predicting things. So you want to base this on heavy analysis of your analytics. So resource hints are great because they let us get that little bit of a head start, but we can go even further than that. we touched on what happens on the network when we're trying to load the front-end site. Let's talk a little bit about what the browser does. So when it gets those assets back, here's what it's doing. It's looking for the HTML, the JavaScript, and the CSS, because it needs these three things to build a document object model and a CSS object model, a representation of all the elements on a page, and a representation of all the CSS that might apply to those elements. Now, JavaScript is included here because JavaScript could change either one of them. It can change the DOM or the CSS object model, because we can do things like document.write. We can do things like change the style on a box. We have the ability to change either one of them. So the browser has to assume that the JavaScript could screw with what it needs, and that's why JavaScript is considered a blocking resource. That's why it's prioritized up front. Once it has a CSS object model and DOM constructed, it creates a render tree. So this is basically what elements are actually going to get rendered onto the page now at this point. Then it goes through a layout process. Think of this as sort of blocks that you're just figuring out where they're going to sit and what sizes they're going to take. And then finally, it paints it all out onto the screen. This path from the network to that initial paint to that initial render, that is the critical path. If you've heard this term, that's what they're talking about. The path from the network to that first initial render. And anything that stands in the way of that initial render happening is critical, a critical resource or a critical process. And we want to reduce as many of those as possible. So here's a simplified example. This is an HTML page. Nothing really fancy going on, but there's still three critical resources here. The first is the HTML document itself, right? The browser needs to request that and load that. The second are the styles. It needs that so it can create a CSS object model. And the final thing is our script, jQueryAcular, which it needs so that it can actually construct, the DOM and the CSS, because it might be influencing that. And if it's Reactular, it's quite possible it's building everything. So let's go ahead and pull these things out one by one. So let's focus in on our script first. What traditionally happens is the browser's parsing the HTML. It comes across a script element. And at this point, it has to pause the parsing of the HTML so that it can parse and execute that script. And then it can pick up where it left off and continue and finish everything. So there's this big gap in the process. We're slowing it all down, this big bottleneck. If we use the async attribute, what this does is this shifts the execution, it shifts the execution. It lets the parsing be alongside of the HTML parsing. So it comes across the script element. It's not going to pause at this point. Instead, it's going to continue parsing the HTML, parse the JavaScript at the same time, and then it's going to pause to do the execution. So it shifts it back a bit. It moves it out a little ways. And then defer goes as far as you can go. Defer says, you know what, this script is not going to do anything to the DOM or CSS object model that matters for this initial render. I just want it all to go to the end. So in this case, parse the JavaScript when you find it, sure, but don't do any execution until you're done with everything else. Just defer it way to the end. So if we use async or defer, that pushes the script out of that critical path for us. It lets that initial render happen earlier. So what about the styles? The styles are a little trickier than they should be, because there's not anything as simple as an attribute to handle here for this sort of thing. The way this works is if we look at the front-end site this is on my MotoX, this is what appears for the schedule page. Now there is a ton of content that is on this page that is not being displayed at all, right? And what I'm looking at, what I see, and what I'm determining how quickly I think the page loads is based on my initial view. What do I see load? Which means that there's only certain chunks of CSS that actually matter, the CSS that applies to these elements. Anything that applies to just the stuff below that viewport, I don't care about as a user. I care about when this paint comes on the screen. So the idea here is if we can pull that CSS out, then we can start to do some clever things to make that faster and get the CSS out of the critical path. So instead of just linking off to the full style sheet, we would run some sort of a tool to grab that critical CSS and inline that within the page, and then you can asynchronously load the full JavaScript or the full CSS after the fact. So we just sub in the inline instead. So what you're basically doing is any CSS that matters is now bundled in that first request back. So it doesn't have to go out and do the whole next request. It can just continue on its merry way very quickly. Now I hear critiques of this, by the way, the critical path stuff. One is that like inlining CSS feels icky. It does. It does. You never really get over that. I've got nothing to cope with that. You're just going to have to deal with it. The other thing that I hear is that it's too complex. It's a very complex process, and is there really any benefit to this? Like, does it really make sense to do it for all the complexities? It is complex. Don't ever do it manually. That does not scale. There's all sorts of build tools that you want to incorporate into your grunt, gulp, but ant thing, whatever you're using. There's some sort of process you can include there, or use some sort of a service. But trying to do it manually is just going to lead to lots of tears. And it is very impactful, as Filament Group demonstrated with the Wired article page that they loaded up over a 3G network. The screen that you see on top here, this film strip, that is the original page loaded over 3G. The bottom film strip is the exact same page. They did not change anything significantly about weights or anything like that. All they did was they asynced all the JavaScript, they asynchronously loaded the web fonts, and they inlined the critical CSS so that the browser could get to that initial render a lot faster. And you can see it comes onto the screen about 9 seconds faster. All of these blank white screens, by the way, these are all passive wait times. So that's how much passive wait we got pulled out of this experience. That's how much less friction there's going to be in that experience for people. But what happens when we can't do this? What happens when we can't eliminate the passive wait time? Because we've all worked on something, right, where there's like some big gap, some server process, something that's really slow, and we just can't make it go away. So what do? That's where we slap a progress bar in there, right? Throw a spinner on it. I hate progress bars. I absolutely hate them. I think everything has a reason for existing. There's probably some great reason for using progress bars, and it's better than nothing, right? But I think it's a fairly uninspired solution to the problem. Progress bars are the hold music of the internet. That's all they are. Every time we put one in there, we're telling people, you know what, hold on a second, it's going to be a few minutes. Why don't you just we're going to throw on some Kenny G, just sit down, listen to some Kenny G for the next 5-6 minutes. It's going to be awesome. We'll eventually get you what you want. All progress bars do is they focus on the waiting. We talked about that active waiting. How long is this going to keep me mentally engaged and active? Hopefully not very long. I like to think my intellectual capacity is slightly above that. Right? It doesn't stick. It doesn't do anything for you. There's much better solutions out there. Luke Wroblewski wrote about, he had built this app called Polar, which was used entirely on mobile. The idea was micro interactions, quick interactions. Bring up a poll, vote on the poll, go to the next one and bring up more. And they had to get a lot of content back from the server, and they had no control, obviously, over the network, right? They've got people using this over 2G networks. So sometimes the spinner is sitting there forever while they're trying to get the content. And they got all sorts of feedback in the early releases about how the app was very, very slow. So they got kind of creative with it. And instead of the progress bar, they instead did what they called skeleton screens. They put these little gray blocks and words for where that content was going to come in. They kind of stubbed out where the content was eventually going to come into play. And as it came back from the server, they would progressively layer this in and fill up all of these little bits. And when they did this, the feedback about it being slow went away. And this is because the skeleton screens shift the focus. They shift the focus from the waiting to the progress. There's now some active waiting I can do because I can now mentally process where all that information is going to go and start to sort things out. It's a subtle shift, but it's a meaningful one. It's focusing on what you don't have to focusing on what you're about to get. And this is a pattern that I'm really happy to see starting to take off on the web. Facebook does this as well. And in the case of that actually kind of washed out on the screen, but there's little bars and boxes where the avatar and everything else is going to load in. And they're just empty divs that they apply some CSS to so that it loads instantaneous. It's right there. And so you got to start to see where that content's going to get stubbed in. In addition, service workers, which I know are going to be brought up when we hear about the Guardian's offline page, service workers enable one of the main architectures that they're talking about with these progressive web apps and service workers is this idea of an application shell, app shell, where it's basically just a small bit of HTML that you're caching locally on the device. And so that little skeleton can come up immediately, and all the dynamic content can get loaded in after the fact. It's all about the perception of the performance. It really improves it. Another thing you can do beyond the progress bars is sort of enhance it a little bit with some information. This is Travelocity. If I was looking for a flight on Travelocity to try and find, apparently, here to go to New York. They have the typical progress bar to the side that it's, there are better options. They used to progressively load things over there, which I like. But what's really interesting is what's happening over here in this box. It starts off by saying, as soon as I enter, it's saying, it's checking with airlines that fly this route. And as this progress bar is moving along, they're going to continue to update this message with all sorts of different snippets. They're going to tell me that they're searching for the shortest flights. They're going to tell me that they're sorting them by this or that. They're finding the best fares. They're going through every step of the process. Now, every time that I give this example, there's 1 or 2 people in the audience that are just going like this. And they're looking at me like, Tim, you don't buy this, right? Like, they're not doing this. They're not doing all of these things when they say they are. Ignore that for a second. What they're doing, though, is they're telling me all the things that I don't have to do, right? I don't have to find the fares. I don't have to sort these things. I don't have to compare airline carriers. They're making me very aware of all the work that I'm not doing, and it's also giving me this stuff to process and think about as it's proceeding. And this works really, really well. There was a study shown specifically on travel destination sites where they compared this with the traditional progress bar, and people were willing to wait up to 6 seconds longer when they got some sort of feedback like this. And they still felt like the experience was better, and it was because they were sort of fed this feedback as they went along. That feedback can show progress. And it also eases anxiety, which is a very important thing because anxiety screws with our time perception pretty significantly. See, what happens in high-stress situations is your brain becomes super hyperactive, and it starts to lay down more and more memories, right? So when you look back at a moment that was high anxiety or high stress, you have all sorts of these memories going on, right? So it feels like it took a lot longer than it really did. So it skews with our perception. So anything we can do to ease anxiety is going to help with the perception of performance as well. So you want to pay attention to those moments like checkouts or anything like that in your experience that might be a little bit more of an anxiety-inducing moment in your application or site, and really pay attention to those. But you do have to test it because sometimes faster is not better. Who expected to see that in the performance talk? The performance guy being like, you should slow down. Yeah, you did. You've seen it. Faster is not always better. There's a great example from Don Norman. He's a co-founder of the Nielsen Norman Group. And he had worked on this app for H&R Block. Tax, who likes doing taxes, by the way? Does anybody enjoy? Yeah, taxes is not a fun thing, right? So this is one of those sort of stressful things to be paying attention to. The whole process of doing taxes is complicated and painful. And so they were building this app, and they'd get to parts of the app where there was some sort of intense calculation that had to happen. Now, it's a computer. Computers are kind of fast. So it could do the intense calculation instantaneous and give the answer. And they thought this was great. People don't need to waste their time. The computer figures it out, and boom. Everybody who used the app was like, wait a minute. This is hard. I've done this. This is hard. There's no way you did all the things you're supposed to be doing in that little bit of time. Like, they did not trust the application at all. So Don's solution to this was to insert an artificial delay. The application could still calculate your taxes instantly, but instead of showing them to you, it first stopped for a little bit, and it's like, hold on, we're doing this, and we're checking this, and it's very complicated. You just got to have some patience for it. And so they had this artificial delay, and sure enough, people were like, oh, this is great. It was a great experience. Now, I would argue that as time went on, hopefully he reduced and eliminated the delay, because the more you use the app, the less you would need it. But it's one of those interesting situations where if going faster was actually not a good thing. We also see this, I've heard this from e-commerce customers in the checkout process. If their credit card verification is too fast, people don't trust it. Sometimes you got to slow that stuff down. Which is why I think I get so excited about performance, because it's not just a blind race to the finish line, right? Performance is actually, it's more choreography than anything else. It's paying close attention to when you have to slow down and when you have to speed up, and paying attention to the users and how it feels for them and how they're using it. Because that's what performance is about. That is what is at the heart of performance. It's about caring about that user experience and caring about how it feels for them to use your site or application. Because how it feels matters, because it's perception that frames the reality. Forget about all the metrics, right? Put the metrics aside for a little bit. It is entirely about how it feels to the user to use your site or application. People want rich, high-fidelity sites. They want immersive experiences. They just don't want to wait for it. And if we shift our focus to be truly user-centric performance, then they won't have to. Thank you.